Hello everyone, welcome to my YouTube channel. This is Philip Noah explaining. If you are new to my channel, please make sure you subscribe so that we can support each other, we can encourage each other, we can help each other. Okay, we have a problem here on transportation. That is one of the concepts in operations research. Goods, this is the question or the problem. Goods have to be transported from source S1, S2, and S3 to destinations D1, D2, and D3. The transportation cost per unit, capacities of the sources, and requirements of the destination are given in the table. This is the table. We have D1, D2, D3, the capacity, have the sources here S1, S2, S3, destination, and we are given here. Are we there? So obtain, this is the question now that we have to answer. Obtain the basic feasible solution using the northwest corner rule. Before I start, I would like to say that northwest corner rule is just one of the methods. You have other methods of finding the feasible solution. You have the Evogil's approximation method is also one of the methods. Lowest cost entry method is also one of the methods. Northwest corner rule or corner method is also the method. So this question requires us to solve it. This problem requires to solve it using the northwest corner rule. Are we together? So I say solution. For us to start solving this using northwest corner method, we'll have to draw or to create another table. Don't worry, it's not difficult, it's not hard. Just understand and you'll get to know it and love it. Are you there? So here's the table. Have just copy 8 here, have 5, have 6, have 120, have 80 here, have 80. Just copy 12, 10, have 10, have 9, have 15, have 3, 150, 80, 80. Oh, here is 50, not here is 50, not 80. 50. Sorry for that. Here is 50. It's 50, not 50. So we add 120 plus 80 plus 80. This is 200 to 80. Then 150 plus 80 plus 150. This is 200 to 80. So it is balanced. 280 is balanced. So for us to apply the northwest corner rule, we have the first step. We have to select the northwest upper left hand here. Are you seeing? Here is our northwest upper left hand corner cell. This one. Select the northwest upper left hand corner cell of the transportation table. Now this is the transportation table, and allocate as many units as possible equal to the minimum between available supply and demand requirement. For example, here we have 120 as the capacity at destination as 150. So the minimum is 120. Are you seeing? And allocate as many units as possible equal to the minimum between available. So this one supply and demand, this is the minimum. So we allocate the here 120. Are you seeing this and this is the minimum, this is the maximum. So here is 120. So this you can say that this one is exhausted. Are you seeing? This is exhausted, but here remember you have remained with 30. 150 minus 120, here you have remained with 130. So we adjust the second step. We adjust the supply and demand numbers in the respective rows and columns allocations. For example, if the supply for the first row is exhausted, for example in this case the first row is exhausted, then move down. As we have exhausted the first row, then move down to the first cell. In the second row, this is the second row, the first column. Are you seeing? So we move to this. Suppose it were that the demand here, or the destination here, is what is exhausted and here is not exhausted, we would have moved to this side. If the demand for the first column is satisfied, then move horizontally, then we could have moved this way to the next cell in the second column, this one. Are you seeing? At the first row. So since this is exhausted, we move to this downwards. Are you seeing? With our 30. Hope you have understood. 150 minus 120 is 30. This is exhausted, so there's nothing we can allocate. Here, this 30 now. Before you continue, I would like to comment that if for any cell supply equals demand, maybe here is 150, here is also 150, then the next allocation can be made in cell either in the next row or the next column. So if it were equal, then you could have moved to the next row here or the next column. And now, but for our case, they are not the same. Hope I have explained why I have moved to this point and not the other way. I think so that now we just continue the procedure until the total available quantity is full. I'm saying, and the total available quantity is fully allocated to the cell as required. So here we move. You have 30. Remember 30 had remained here. Are you seeing? After allocating 120, so 30 is, you have already exhausted this, so we move this way. Hope you are following. Here after giving this 30, we remain here with 50. Are you seeing? 80 minus 30 is 50. Now here at 10 we give 50, and this 50 now here is exhausted since we can remain with 50, and here we have 80, so we have remained with 50 here. Are you seeing? I have remained with 50. So this 50, since this is this row here is exhausted, here is exhausted, here the capacity is exhausted, we move downwards. Here to the second row, to the next row, sorry, the next row, so that we have we move to the next row. Remember here it was 50. Now after allocating this 50, we remain with 30. So here you have 30 here is exhausted. We move to the next column. Since here is exhausted, we move to the next column. Remember, after allocating here 30, here it was 80, now it is 50. So here we give 50. You can see that 50. So here is exhausted, he is exhausted, and we are done. So to get the total cost is just, now we multiply 8, this 8 times 120 times 120 plus 15 times 30 plus 10 times 50 plus 9 times 30 plus 10 times 50, so that we have 960 plus 450 plus 500 plus 180 plus 500, and we get to 2590. Are we there? Hope you are together. And up to that point we are done. We have already obtained the basic feasible solution for this transportation problem using the northwest corner rule. Thank you so much for watching. Please make sure you do subscribe, and you can leave a comment, maybe to comment something on my teachings or to suggest a video. You teach me, remember, you teach me, I teach you. Let's make mathematics fun and continue learning mathematics. So thank you so much. Till next time, bye bye.